Geometry section 5.1 deals with bisectors, medians, and altitudes. Now there is a lot of vocabulary words on this one. I apologize guys, but please make sure that you are familiar with them and that they're on your notes for the next class period. We come up with 3 new theorems and a whole bunch of new words. The first word that you need to understand is the term concurrent or concurrency. That's just basically where, you know, if 2 lines intersect, the place where they intersect is called the intersection, point of intersection. But when 3 or more lines all meet together, it's called the point of concurrency. So when they are concurrent, that means we're dealing with 3 lines that all meet in one specific point. So a circumcenter is basically the concurrent point of perpendicular bisectors. Now, it's in your books, in your definitions of perpendicular bisector. It's basically a line that bisects, so it cuts in half perfectly a side, and it's perpendicular, so it hits it at a 90-degree angle. So here in this triangle ABC, I found all of the midpoints of the sides. So basically I'm going to create a line that hits it exactly at 90 degrees for each one. Okay, and this point right here, this is the circumcenter. Okay, the circumcenter, so let's call this J. So this says that if J is the circumcenter of this triangle, that means all the lines AJ, BJ, CJ, so that means if I took a line and drew it from each vertex to here, they would all equal each other in distance. Okay? Sorry. It's the world's ugliest line. So this is telling me this equals this equals this. So again, I find the circumcenter, which is where all the perpendicular bisectors meet, and from that point to every vertex is equal length. And that's the circumcenter theorem. Incenter is the concurrency of the angle bisectors. So if you remember what angle bisector is, it's the term bisector means cut in half, but in this time we're not cutting the line in half like a line bisector, but we're cutting the angle in half. So if I have C, and I've cut that in half, making this equal to this, okay, and I've cut this in half, making this equal to this, and I've cut this angle in half and making this equal to this, then I have what is called the incenter. Okay? And we're going to call this K. Alright? And where it meets on the other side, so you see how K meets Q on this side, K meets P on this side, K meets R, wherever it meets on the other side, they're all equal. So this is equal to this, is equal to this. And that is term of an incenter. Alright? So, don't forget to go ahead and copy that down, pause it, in the vocabulary. We have 2 more. One is a theorem, one is just for informational purposes. This one is the Centroid theorem. So far we've had the circumcenter, which is where the perpendicular bisectors meet. We have the incenter, which is where the angle bisectors meet. The centroid is the concurrency of a median. Okay? And the definition of a median you should have is from the vertex to the midpoint. So I find the middle, okay, of each line, right? And then I go from the vertex to the middle. This point right here, okay, is a centroid. And these are all medians right here. And it tells me here that when I do that, I cut this and I have, let's see, this is, let's call this L. They want L to be the centroid. And so basically this long part, okay, this short part, if you multiply that by 2/3, you get this part. So this is 3 times larger than this part right here. And this is important because sometimes they'll give you one side, but they won't give you the other, and that's what you need to find. So this is the more complicated one. The longer part is 3 times bigger than the smaller part. Alright? And that is a centroid. The orthocenter is the altitude. So I don't know if we've been over what altitude is, but an altitude is basically you go from the vertex and you go straight down to hit the side at a 90-degree angle. Doesn't matter where it hits a side, but it has to hit it at a 90-degree angle. Same thing with this. You take this and you hit it straight down to a 90-degree angle, and this one straight down to a 90-degree angle. This then is our orthocenter. So from vertex to side perpendicularly. Okay, this is called, this altitude is this right here. Right? So it's all new vocabulary, some rules. You'll have them in your flipper to check back. It's just important to understand when they're talking about, a median, you know what that means. When they're talking about perpendicular bisector, you know what that means. And you're going to be doing some proofs with it, as much as that probably makes you super happy. So for example, we have a problem here. And it says points U, V, and W are the midpoints. Find A, B. So basically, this is this line is a vertex to a midpoint. So vertex, midpoint. And the definition of a vertex to a midpoint, they call that a median. Remember, so you would look back, and these are all medians. So therefore, this is called the what? The centroid. Right? And in the centroid, if you look back in your notes, it's saying that this is 2/3 this size. Sorry, it's wrong. It's not 2/3 this side, it's 2/3 the entire thing. My apologies on that. So again, this small part is 2/3 the entire line, not the other side. So make that correction on your notes prior. My apologies. So what that means is that in this case, I have my small side XU equals 2/3 the size of my entire line. Oh, sorry, let's call this L. So UL is 2/3 the entire thing, which is XU. Right? And I know here that VL equals 2/3 the entire thing, which is VY. And then this one is WL equals 2/3 ZL. Now, once I have those, then I can just fill in the numbers they give me and solve. Okay, so again, the key to this is to find what they're talking about. They didn't actually use the keyword median, but because we knew that it's from a vertex to a midpoint, we call it a median. Once that, then we go ahead and establish the equation. And when I establish these ones, then I can go ahead and plug them in. So here I have UL is 8.7. 8.7 equals 2/3 of the whole thing, which is 3B plus 2 plus 8.7. Alright? So, right, this whole thing. So that means that I have 8.7. I'm gonna get rid of this 3 by multiplying both sides by 3. So 8.7 times 3 is 26.1. This 3 and this 3 cancel out. So I end up with 2, which I'm going to distribute. 6b plus 4 plus 8.7 times 2 is 17.4. Okay, now I can add these together. $21.4. I'm going to go ahead and subtract both sides by 21.4. Okay, these and these cancel out, and I have 26.1 minus 21.4. Sorry guys, that's Miss Grace. Which is 4.7 equals 6b. And then I'll divide both sides by 6, which gives me b equals 0.783. Okay. I'm running out of room, so basically it's the same thing. You're going to plug it in and solve for each one. And then you should be getting for A, B, and C. So go ahead and finish this and also do page 274, number 2. So complete this and page 274, number 2. I'll see you in class tomorrow.